Dear researchers and scholars, this is the introductory information for using iFogSim for computing latency delay, power utilization, network utilization, and the cost that should be incurred for a given application that is deployed on a given IoT infrastructure. Means for a given application deployed on a given IoT infrastructure is going to simulated using iFogSim simulator for computing latency, power utilization, cost incurred, as well as network utilization average to compute, as well as to find the optimal solutions with respect to your requirements. So to do this, before discussing about iFogSim simulator, it is good to know how IoT applications are developed or implemented. And second thing is we need to know how IoT infrastructure, means hardware, is deployed all over the smart city or across the geographical area. So this is the second point. First point is how application is developed in modular way. As second thing is how the hardware infrastructure is deployed all over the smart city or across the geographical area for deploying these applications. After that, how this application performs over the hardware for a desired latency, power utilization, cost incurred, and network utilization. These are all the parameters we wanted to minimize for a given application on an infrastructure. How to do this? This will be simulated using iFogSim simulator. So today our main agenda is to discuss about the introduction of iFogSim. So here I divide this information into three part. First part is application part. What kind of applications could be you implemented over IoT infrastructures. So for this case study, I take the latency sensitive online game that is called EEG tractor beam game. So let us discuss how this EEG tractor beam works. So here what happens, multiple players who are having their own Android handset. So here Android handset is an edge device. So it is connected to an headset via Bluetooth. Means there is an headset, each player has to wear it, and it is connected to Android smartphone. And again smartphone will have another hardware called display, means actuator, which will display the concentration, means output. See, player wants to know the result. No, result will be displayed on the actuator, LCD display, or you can call it as that. So here what happens, headset serves as a sensor that sense the focus level, or individual player how much is focused or concentrated on playing the game. That is measured by the headset, and that signals are transferred to the Android phone via Bluetooth. Similarly, his concentration is, again he wants to know how much he is focused on the game, so it should be displayed on the actuator. Similarly, many people are playing in the geographical area, so other players who are playing with him as a group, 10 members or 5 members. So this group, he wants to see the focus level, of other players. So that should also require to be displayed on his smartphone display, that is actuator. So it is also going to be displayed on this. So the winner of the game, how we decide at the end, winner of the game is decided by how much concentration he is having. Based on that, see, okay, I'll read out the problem, you will understand it clearly. The game runs as an Android application on a smartphone. The application performs real-time processing of EEG signals sensed by EEG headset. This EEG headset is weared by the player, and from that headset, actual real-time information is sensed, and that calculates the brain status of the user. Brain state means how much he is focusing on the game. The applications displays the game, shows all the players on the surrounding target object. Yeah, see there, here what happens, there is an object, so people who are playing, for example, five people are playing, five people are all surrounding the object, and they are trying to pull that object towards them, and ultimately who focus very intensely will pull the object towards him, and he will be declared as the winner. That is so the game shows all the players on players on a ring surrounding the target object. Each player can exert an attractive force onto the target to proportion to his level of concentration. His level of concentration. What is the level of concentration? That is the proportion he possibly take that. In order to win the game, the player should try to pull the target towards himself by exercising concentration. Means more concentration. If he pull it with more concentration, it will coming towards him, and he will be like winner. While different other players, so this is about real-time processing requirements, that requires that application be hosted very close to the source data. See, in reality, this application, if you hosted, in reality, headset collects the intensity or his focus should be displayed immediately to him. No? So if the application is running at the mobile itself, it will give a quick response. If the application is on the cloud, so headset captures the data and transfer to the mobile device, means Android phone, and again it moves to the cloud, and cloud should compute the intensity of the particular player, and it should collect the intensity of the other players also together, and then it sends back. It takes time back for the display, and this, and then user will see whether he wins or not. So it takes time. So here what happens, this application demands application should be hosted at the Android phone itself, then response time will be quick. But here, if that is the case, if application is hosted in a edge devices, how do you coordinate them? Because every individual needs to know other players state also, and you want to know who is the winner, and it is a real time game. So at the time of playing, everybody should know everybody is with what force is pulling the object. No? So till the end of till the winner is declared. So here, so this is the kind of application. So in this application we divide into modules, means three modules here in this application: EEG, tractor beam, game. So this is an application we modeled into three models. One model called client. The client model's responsibility is to collect the output of the headset, means that realistic output, means in brain's data, and that data after collection it needs to be filtered for noise. So the data, we have to remove the noise from the data whatever collected from the headset. After cleaning the data, that should be sent for another model, and that model is responsible for computing the concentration and strength of the concentration. So that model is called concentration calculator. Once the concentration calculator computes the focus level, some intensity level, and it will be sent back to the client, and that concentration focus level received by the client is again transferred to the actuator, means display, so that the the player will know the intensity at which he is playing the game. But in this scenario, what happens, one user scenario is covered, but another user scenario, like this 10 users are playing. So there is 10 clients, means client is a model. There are 10 models are running on 10 mobiles, 10 Android mobiles. So here what happened, and so each client will receive the input from the headset of the particular player, and then it cleans it again, it transferred to the concentration calculator. So this transformation means traveling data from one model to another model. There is a delay because of transmission delay, correct? So like this, there is a delay. Sometimes if both the model, client model and concentration calculator model, both are in a same mobile device, means Android mobile, then transmission time is not there, but computation time will be there. But computation time, Android mobile have a processor that computation speed is very low, so that calculation will be delayed and user will not get the proper response. That's why, so these are the issues I am talking about. There are solution, I will tell that in future. So like that, the given application is divided into three models. One is the client model. Responsibility is to collect the information from the headset and cleaning it and transferring it into the concentration calculator. Responsibility of concentration calculator is to collect the information sent from the client and then compute the concentration and send back the concentration to the client. Again, client will actually display it back to the mobile device. So, but where this client software sits, we will decide later. Where this concentration calculator model sits, we will decide later. But concentration calculator has two jobs. One is not only computing the concentration, it has to send the concentration back to client, means who wanted it, and again this concentration of a particular user, means particular player, should be sent to the coordinator, and coordinator is the third module which collects the concentration of all the players. If there are 10 players, 10 players concentration will be collected, and then it should be sent back to all 10 people. 10 people concentration will be sent back to all 10 clients, so that the client will display all 10 people concentration on the screen, so that individual player will know not only his concentration strength but also the concentration strength of the other player, and ultimately winner is the one who plays the game with highest concentration. So this application, what I said, this application, EEG tractor beam game, comes with three model, and that is called client, concentration calculator and coordinator. So this is the application. So this is a software that has three models. This is to be deployed on the IoT infrastructure, so that people have to play with good response time. So player should not feel that system is very slow, response is very low, and you will lose the interest. If it is slow, you will lose the interest. So that should not happen. For that, we need to simulate this application on a given IoT infrastructure using iFogSim simulator to understand what is the delay, what is the response time is coming. So how we can alter these three model, means placement of these three model on an hardware to get the, see, there is a hardware, there is a set of hardware. We need to put these three models on the hardware. How we are going to deploy these models on the hardware? So our objective is to deploy is right, but deploy in such a way that response time should be fast, means delay should be reduced. So that is the problem. So today, now I am going to the second part of this. Second part is IoT infrastructure. Before going to that IoT infrastructure, so whatever we discussed, it will be explained in the diagram. You can see this is an EEG headset. Headset will send the information, and client model will get that information and cleans that information, means removes the noise and like that, and then this model, client model, will send the cleaned data, sensor data, to the concentration calculator. concentration calculator computes the concentration and sends back to the client, so that client will display back the focus strength of a particular player. Means what I say is EEG, display and the client, these three should be placed in a hedge device like mobile, Android mobile may be good. We will see where to place. Right now software models are these: client, concentration calculator and coordinator are the software model. Which model should be placed in which hardware, we will decide it later. But you please show that client model and concentration calculator both are in the same Android mobile. Then what happens, transmission delay will be zero, but computation cleaning is one job that is done by the client. It takes some time because it uses processor time, computation time, and after cleaning, calculating concentration will also take time. So processor speed is very important. Even though there is no transmission delay if client and concentration both models are put in Android mobile, but the thing is mobile should be enough strength, means speed, to do the computation. So it is like trade-off. Putting models in different layers will incur transmission delay but reduces the computation delay, computation time. So we have a trade-off. So that's why. So we will discuss the thing like that. Similarly, concentration calculator sends back the concentration to the client and client will display it. But the after that concentration calculator has another job. It should send it the same concentration of a particular user to the coordinator, who is responsible for receiving the concentration of all the players. Means 10 players, 10 papers it should receive, and it should update all clients, means 10 mobiles with 10 concentration. So that display should show all players concentration, so that every individual player should know the concentration of, means strength of the concentration of every player. And ultimately winner is the player who is having highest concentration while playing the game, because concentration is the one parameter used to drag the object towards them. So this is the software design, and this is the data flow diagram kind of thing. So now we will discuss about how IoT infrastructure will look. So IoT infrastructure will look. So this is called physical network for case studies. So for this particular case study, physical infrastructure. So there will be an headset. See, there is an headset. It's a million instruction. Headset means that is capable of this million instructions. It sends for 5 milliseconds. Means strength. So hardware. So see, now the physical topology of the case study is modeled in iFogSim. See, it's like this. So here you can see, one second, you just be same diagram I have in another, I will show that with you. Okay, I want to minimize the size, view full screen not required. Okay, yeah, fine.